Yeah, we can see the whiteboard.
Yes.
Okay, good. So differentiation rules. Now, before we start discussing different tools we use to differentiate functions, I want us to get some basic derivatives of functions: constant function, cosine function, sine function, and exponential function. Then we'll be able now to discuss rules that follows on derivatives. So let's begin by constant function. So a constant function is a function of the form f of x equals to k, where k is a real number. So if the question would be, if f of x equals to k, what is dy dx? Which simply means the derivative f prime of x. So we'll still use definition to get the answer to the question. So the derivative f prime of x, which is dy dx, is given by limit as h approaches 0 of f of x plus h minus f of x divided by h. Now, f of x is given by k. So this is what is given in the question. If f of x is given by k, what is f of x plus h?
K plus H.
Correct, k. So remember, constant means not changing. So regardless of the input you put for f of x when f of x is k, the answer remains to be k. So f of x plus h will remain to be k. So this is k. So then now this implies that f prime of x, which is dy dx, will be limit as h approaches 0 of where this f of x plus h is k minus f of x is k divided by h. And what is k minus k?
0.
0. And what is 0 over h? 0 over h? Zero over h?
Zero.
0. Correct. So what is the limit as h approaches 0 of 0?
Simplify them. 0.
0. So we are saying, in general, if f of x, if y equals to f of x, if k, then f prime of x, which is dy dx, will be given by 0. So in other words, we are saying the derivative of a constant is always 0. So take that into consideration or add it to your toolbox. That if you are doing derivatives and you are having a constant function, then the dy dx will always be 0. Then another special function that I would like us to discuss is the exponential function. Given by f of x equals to e power x. So the question here, given f of x is e power x, what is f prime of x? So we'll do the same thing. F of x solution is given by e power x. So which implies f of x plus h will be?
E power x plus h.
Correct, e power x plus h. So therefore, by definition, we know that f prime of x is limit as h approaches 0 of f of x plus h minus f of x divided by h. So in our case, this implies f prime of x will be limit as h approaches 0 of e power x plus h minus e power x divided by h, just by replacing f of x plus h and f of x. Now, in your Form 2 work, if I give you a power m plus n, can also be written as if I want to separate m and n, will be a power
M times M N.
times a power n, okay? So the same thing here. This exponential also obey the same laws of exponents as we did in Form 2. So this will be limit as h approaches 0 of e power x, then I multiply by e power h minus e power x divided by h. We have not performed miracles to that expression. It's exactly the same. The only thing we are doing is to apply law of index. So what can you say about the numerator?
That's a common factor.
And we can factor e power x, correct? So this implies that f prime of x will be limit as h approaches 0 of e power x into e power h minus
1.
1, then over h, correct? Don't forget that our limit is a function of h. So then e power x can be factored out because it's just a constant. It doesn't, e power x does not depend on h. So this can be written as e power x limit as h approaches 0 of e power h minus 1 over h. Then I want you to go back to your toolbox and tell me what is the value of this limit. Go to your toolbox and tell me this limit reduces to which value?
1.
1, correct. So this will be e power x times 1 So because this actually this one, which is just e power x. So therefore, in general, if f of x is e power x, then f prime of x is also e power x. That the derivative of the exponential is the same exponential, so it doesn't change. So if y equals to e power x, dy dx is e power x. So say sine function. So the question is, given y equals to f of x equals to sine x, find dy dx. So we'll do the same process. We say f of x is given by sine of x. This is what the question is. Then if f of x is sine of x, what will be f of x plus h?
Sine of
What is
x plus h
sine of? Will be sine of?
into brackets x plus h.
Yeah, into brackets x plus h. Then I want you to go back to your toolbox and read for me the definition of, if I have sine of a plus b, is the same as sine a plus b equals
Sine cos
Sine
a
of
plus cos a
sine a
sine
cos
b
b
plus cos a sine b.
plus cos a sine b, correct? So we apply the same thing to this, and we'll have sine of x times cosine of h plus cosine of x times sine of h. This is just using this definition. So then now we know that the derivative f prime of x, which is dy dx, is limit as h approaches 0 of f of x plus h minus f of x divided by h. This by definition. So let's put in the quantities we have. So this implies dy dx, which is f prime of x, will be limit as h approaches 0. Denominator remains to be h. Numerator will be sine x cos h minus plus cos x sine h minus f of x, which is sine x. That is just by definition when we replace f of x plus h and f of x. I hope up to that point we are together.
Yes.
Good. So what we do now, we have 3 terms. Let's bring terms which have sine x together. So I can derive this as limit as h approaches 0 of sine x cos h minus sine x, then plus cos x sine h divided by h. I hope you are in agreement with that, that when you have addition of three terms, you can always rearrange them. Eh?
Yes.
Yeah. So then what we do, the first two parts, these two terms in the numerator, sine x is common. So I can factor out sine x, and I rewrite this one as limit as h approaches 0 of sine x into
Cos h minus 1.
cos h minus 1, then plus cos x, then sine h, then over h. Then, if you remember your primary work, if I have this fraction a plus b divided by c, can also be written as
A over C plus B over C.
correct. This can be written as a over c plus b over c. So I want us to apply the same to this difference quotient, that this part with sine x we divide by h, this part with cos x divided by h. Then we can rearrange and rewrite this limit as, so this will be limit as h approaches 0 of sine x into cos h minus 1 divided by h plus cos x sine h divided by h. Then I put all this in brackets. There's no miracle you have performed. You're just playing with this algebraic, this expression, this fraction. Now, remember we are dealing with limits. And in the previous class, we discussed that you can define limit of sum of two functions as limit or as the sum of the limit of the two functions. So therefore, you supply limit to this first function, then limit to this other second function. So you can write this one as limit as h approaches 0 of sine x into cos h minus 1 divided by h plus limit as h approaches 0 of cosine of x sine h divided by h. So just using limit properties. So for those who are following, what should we do to the first limit? How can we simplify the first limit at this point?
0.
Before you get that 0?
Product.
We can apply, but even before you go to product rule for limits, what is the most natural thing to do? If you recall how we were playing with the exponential function.
Substitute.
Substitution is going to mess it, will mess it up. Limit depends on which variable?
Quotient.
This limits we are defining depends on which variable?
H.
H.
H. So the limits we are computing depends on the variable h. So which means anything that doesn't have a h is a constant, okay? So then what can we do to this? We factor out sine x, because the limit variable is h, does not x, that x is not affected. So we factor out sine x and have limit as h approaches 0 of cosine of h minus 1 divided by h, plus second limit will be reduced to
Cos
cos
x
limit
limit
as
h approaches 0 of sine h over h. Good. Then I want you to go to your toolbox and tell me what is the value of this limit and what is the value of this limit.
The first one is 0.
Yeah, this will be 0. The second one?
1.
1. Correct. So 0 times sin x is just 0. So this just reduces to 1 times cos x is just cos x. So let's just have this as cos x. So in general, if y is sin x, then dy dx is cosine of x. Add this to your toolbox. It will be very useful as we move to the next step, that the derivative of a sine function is always a positive cosine function. Then lastly, on these special functions, before the rules, is the cosine function. So the question here is, if y is cos x, what is dy dx? So this is the question that we want to answer in this subsection. That we have a cosine function, and then we need to say the derivative of this cos function. So we play the same game. So solution here, we have y, which by default is f of x, is given by cosine of x. So this is already given. So once you have f of x, you need to define f of x plus h. And this will be given by
Cos of into brackets x plus h.
correct cos of x plus h. Then I want you to go to your toolbox and tell me what is cos of a plus b.
Cos A, cos
Cos
B
A,
minus
cos
sin
B
A
minus
minus
sin
sin
A,
A sin B.
sin B, correct. This by definition. So it's the same thing we do here. So cos of x plus h is the same as cos x cos h minus sin x sin h. That's by definition. Then we know that the derivative f prime of x, which can be written as dy dx, is limit as h approaches 0 of f of x plus h minus f of x divided by h. So this will mean our derivative f prime of x will be limit as h approaches 0, then cos x cos h minus sin x sin h. Then I subtract cosine of x, everything divided by h. Just by substituting what we have for f of x and f of x plus h into the definition of the derivative. So who can tell us the next move?
Rearranging.
Rearranging so that cosine x are together, correct? So we'll have limit as h approaches 0 of cos x cos h minus cos x minus sin x sin h divided by h. The beauty with these things is that once you know how to deal with one, then the rest actually follow the same pattern. So what should be the next step from here?
Factor
Common
out.
Factor
factors.
out cosine x, correct? So we'll have limit as h approaches 0 of cosine of x into cos h minus 1 minus sin x sin h, everything divided by h. Then what follows?
Make it into two different fractions.
Yeah, we divide each part with h. So this will be limit h approaches 0 of cosine of x into cosine of h minus 1 divided by h minus sin x sin h divided by h. Then all this I put in brackets. Then what follows?
Constant.
So supply limits to each of the two parts. So I'll have limit as h approaches 0, cosine of x into cosine h minus 1 divided by h minus limit as h approaches 0 of sin x sin h divided by h, correct? So what will be the next step from there?
Constant multiple rule.
Yeah, so factor out cosine x here and then sin x here because limits are functions of h. So the constant, which are functions of x, are not affected. So factor out cos x, limit as h approaches 0 of cos h minus 1 over h minus sin x, limit as h approaches 0 of sin h over h. So this is now where we go to our toolbox and get the value of this limit and get the value of this limit. So the first limit is equivalent to
0.
0. So here, this is equals to 0, and this other one?
1.
1. So we have cos x times 0 minus sin x times 1. So what is the final answer now?
Sin x.
Negative sin x.
Negative sin x. So in general, given y is cosine of x, then dy dx is negative sin x. So add this to your toolbox. We'll need it in the future. So having now known the base derivatives of those special functions, which actually will be most applicable in most of the functions and the computations we'll be doing, we will be ready to discuss the rules. So I'll spend a few of your minutes, say 10 to 15 minutes. I give a small break and then I'll come back to state the rules. So we'll resume at 12:50.